LeetCode 214, shortest palindrome. You're given a string S. Convert S to a palindrome by adding characters in front of it. The strategy to find the shortest palindrome by adding characters to the front of S is to get the length of the longest palindrome from S at index 0. In the case of ABBAZX, the answer to that question is 4. We get a substring from index 4 to get the tail. Reverse that, prepend that reversal to the front of the string, and we get XZ, ABBX, ZX. And that looks like this. And that is, as you can see, a palindrome. That is the strategy in a nutshell. But it is a little more challenging than it seems on the surface. So we're going to cover a few examples. I'm going to go over the strategy. We're going to look at a simple example, then a harder example, and then we're going to look at an example that exposes an inefficiency in our algorithm. See how we can fix that in the solution. I've gotten pretty good performance, although varied, on my solution here. This I got on January 31st, almost a week ago, and I didn't do as well on memory. Beats 11.11% on the memory, but beats 100% on performance. And this is my code here that got us to that. It's a little bit different, and it doesn't actually leverage the optimization. I took it out when I ran it and got faster performance when I took it out. It was kind of a fluke. But enough of that. Let's get right back into the solution here. And I encourage you also to read the other solutions, because there are some creative solutions besides mine. Step 1, get the length of the longest palindrome. For this input string, it's 4. We get a substring from index 4, reverse that, and prepend it to the input. We're going to find a palindrome from an expanding window strategy from the center. It's more efficient because we have fewer iterations. Compared to brute force, for brute force solution, we check the start of the string pointer, index 0, and then we get the end of the string pointer, length -1, and we compare the two. The character at the start pointer is the character at the end pointer. So long as they don't overlap, we're going to keep going on that loop. But if they're different characters, then we return false. And so that strategy will work, but for our problem, it won't be optimal. And it won't pass because it'll be too slow. Our input string can be from 0 to 50,000 characters long. And so let's look how that would work. We start with a start pointer and an end pointer. 0 and length -1. If they're the same, we would increment start, decrement end, increment start, decrement end, increment start, decrement end, until the pointers cross. And so that would be as long as our string n, performance n. But if it's not a palindrome, then instead of starting from n-1, we have to start from n-2 and repeat that entire process. And then we have to repeat that entire process again and again and again until we get a palindrome, which could, in worst case scenario, we don't get a palindrome. We get to index 0, and that's the best we can do, as shown here. And so that won't work if we have to do that 50,000 iteration times 50,000. That's going to be way too long. So instead, we're going to check the middle. And you can see by checking this middle character D, well, that doesn't form a palindrome. This C doesn't form a palindrome. This B doesn't form a palindrome. So we only have to do half as many iterations. That's a little better. So our strategy is going to be to find the mid index see if that's a palindrome that reaches index 0. And if it is, we're going to return the length of that palindrome to a different function, which then gets the substring of the tail, reverses that, and prepends that to our input string. So the shortest palindrome function first gets the midpoint. It does that by calling math.ceil length divided by 2 minus 1. So let's just go over that real quick. If we have length divided by 2, if we have an 8 character input string, length divided by 2 is 4. Ceiling is 4. Minus 1 is 3. So that gives 1 to the left. If we have a 7 character string, length divided by 2 is 3.5. Ceiling is 4. Minus 1 is 3. So in both 7 and 8, we have 3. And so for an 8 character string, it's going to be 1 to the left. Okay, so we've gotten the input string there. Now we want to see, we've got our input string, we've got the midpoint, set I to be mid. As long as I is not -1, I minus minus. In the body of the loop, we're going to get this destructuring statement is going to get left pal length. So if we get -1 back, we don't have a left pointer. So we got to the start of the string. And then we're going to get the length property, which is just the remainder of the characters in the string after our palindrome. And then we're going to take those characters, reverse them, and return the result of adding that reversed tail to our input string. And that's called in prepend tail. So what we're looking for here is we're looking for L is -1. Now if L is not -1 from our I pointer, we go through this loop, we call get left pal length, L is not -1, then we go I minus minus. So we're going to try a character that's 1 closer to the left than mid. And we're going to keep on going and keep on going until we get L is -1. And eventually we will. Eventually we'll get 1 character in the string and there won't be any more characters to the left, and so that will be -1. In the worst case scenario, we get to the start of the string. We don't get any palindrome except for the first character, which once again is a palindrome, I have to say. The empty string and 1 character are palindromes. So we have a guard clause here. If s.length is less than or equal to 1, we're going to return our input string. Okay, so then we don't enter the loop. So remember we call get left pal length from our loop. And then we return L and length in our loop in shortest palindrome. So we're looking for -1. So get left pal length now has this destructuring statement, which gets back a list from same char outside bounds. We're going to take a look at that in a second here. It's going to loop through until we get -1, and it's going to try to compare those L and R pointers and decrement L and increment R to see if we have a palindrome from that potential middle of a palindrome spot. And when we get -1, we're done with the loop. If the characters don't match, we're done with the loop. Let's look at same char outside bounds. Same char outside bounds gets past the same parameters that get left pal length got. The input string and the index. We're going to first get the character that we're on. That's going to be pal char. That's S at index I. And we're going to try to look for an island of characters. This is what that strategy looks like. If we have an island of the same character, in this case C, then we don't have to worry if it's odd or even. And then we can look to the character to the left and the character to the right, and then see if those match. That's going to be a different expanding window strategy. The first expanding window is to just get all the characters that match, and that's the center. So the way we do that is, well, we start with L and R are equal to I, decrement L. So I was, what do we have in this one? I is going to be 2. L is going to be 2. R is going to be 2. Now we decrement L. L is 1. Is 1 the same as palchar? Yes, so we're going to decrement that now. It's not the same as palchar, so we're done with that loop. And then we do the similar sort of thing with R. And we take R is 2. It's the same character. We increment R in the body of the loop. That's S at index 3 is the same as palchar. We increment R again. Now R is 4. A. S at index 4 is A, not equal to C. Palchar is C. S at index, we started out I as 2. So then we're going to return 0 and 4 back to get left pal length. 0 and 4 come back. L is 0. S at index 0 and R at index 4 are both A. So we're going to decrement L. Now L is -1. And increment R, 5. We're going to return -1 and 5. Why? Well, because we're done with a loop. L is -1. Okay, so we return -1, 5 to shortest palindrome. So shortest palindrome got back -1 and 5. What does shortest palindrome do when L is -1? It calls prepend tail. So let's take a look at prepend tail. Prepend tail gets our input string and 5 in this case. It checks to see if 5 is equal to, length is equal to s.length. Remember, our input string in this example was ACCC. A. That's 5 characters. A, C, 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 A. 5 characters. So we return the input string. Itself is a palindrome and the shortest possible palindrome from that we can get from our input string. Now we're going to look at another example. One that explores a little more stepwise. And then we're going to go into our final example where we see where we might be able to improve this. And then we're going to work on the improvement. But we're going to build up to that. So we're going to start with our example that we started in the beginning. A, B, C, D, D, C, X, U. 8 divided by 2 minus 1 is 3. We call get left pal length with S and 3. Pat calls right away gets same char outside bounds with S and 3. We get our palchar from same char outside bounds. S at index 3 is D. Okay, then we expand that window to be D and D, DD. Now, what's going to happen? We try to first when we go same char outside bounds, we have to go left first. So L is going to be 2, and R is going to be, R was 3, and then it went to 4, and now R is 5. Okay. Same char outside bounds is going to return L as 2 and R as 5. Now, that's going to return to get left pal length, which gets back 2 and 5. And it enters into the loop. Well, the while loop is not -1. Oh, that L is not -1, it's 2. We're going to check also to see if the character at L and the character at R are the same. C and C are the same. We decrement L, and L is going to point to 1, and we increment R, which is going to point to 6. It's going to be 6. R is now 6. And we check those characters. Respectively, those are B and X. Not the same. So we're going to return. We're going to exit that loop and return from get left pal length to shortest palindrome 1 and 6. So we get back 1 and 6. Shortest palindrome is looking for L is equal to -1. We got back 1 and 6. So shortest palindrome now goes I minus minus. I was 3 in our last iteration. It was the exact middle. It was the middle for our 8-character input. So I minus minus is 2. So now we're going to call get left pal length with S and 2. Get left pal length calls same char outside bounds with S and 2. It now looks or decreases the L pointer to 1. That's a different character than our pal char. Remember, same char outside bounds gets pal char. S at index I was 2. Our pal char is C. And we decrement L. L is now 1. S at index 1 is not C. And then we go to the second loop in same char outside bounds. Increment R. So we increment R from 2 to 3. So R is now 3, and S at 3 is different. It's a different character. That's D. So now we're done with that one. So we go back to get left pal length with 1 and 3. Get left pal length has L is 1, so we're not done with the loop yet. And we're going to check character B and character D, and those are different characters. Remember, this is a different check. We're not checking to see if they're the same as C. Get left pal length checks to see if the character to the left is equal to the character on the right. Same char outside bounds is only concerned with an island. Okay, so get left pal length does a different type of expanding window. It goes here and here. So the leftmost character wasn't reached in get left pal length. We didn't get that. We got 1 for L and 3 for R. So we're going from 1 and 3 to shortest palindrome. Shortest palindrome passed us 2 last time. I was 2. Now I minus minus, I is 1. Shortest palindrome calls get left pal length with S and 1, which calls same char outside bounds with S and 1. Same char outside bounds decrements our L pointer to 0, increments our R pointer to 2. The character at index 0 is not the same as B, so we're done with that loop. And then the character index 2 is not the same as that B, so we're done with that second loop. And then we return that 0 and 2 to get left pal length. Get left pal length checks to see if the character in index 0 and the character in index 2 are the same character, and they're not. So then that returns 0 and 2 to shortest palindrome. Shortest palindrome gets back 0 as L pointer, so it's not done. So now we have to decrement I to 0 from 1 in shortest palindrome. Shortest palindrome calls get left pal length with S and 0, which calls same char outside bounds, which enters into the first loop, L minus minus. L is 0, L minus minus is -1. S at -1 is undefined. That's not A. And then we go R. R at index 1 is B. It's not the same as A. So now we have our L pointer is -1 and our R pointer is 1. It's returned to get left pal length. Get left pal length sees that L is -1, doesn't enter the loop, and it returns -1 and 1 to shortest palindrome. Shortest palindrome gets back -1 for L and 1 for R, or we call it length in shortest palindrome. We get back length. So we're going to get a length of 1. That's the length of the longest palindrome from the start of the string. L is -1. We're going to prepend the tail, given S and length of 1. So we're going to get a substring from index 1, a substring from our input string. And this is a substring that we get back. It's just the remaining 7 characters. Reverse that and add the reversed substring to our input string, and then return the result. And that's what that looks like right there. Long result right there. So in this case, I'm going to go over that real quick here. We get a slice from index 1. Split that. That's this whole thing. Get an array, reverse the array, and then join the array on the empty string. And then add that to S, and that's what we return. That's just an example. So now we're going to go into our third example of stepping through this code, and hopefully now you're very familiar with what this code does. In this last example, we're going to take a look at the string ABC CCB. Right, 6 characters. What's the middle index? 2. Character is C. Same char outside bounds is going to expand that to CCC. Can you spot the inefficiency now? I hope so, because CCC, well, if we expand that to be a palindrome, it won't meet index 0. We have 2 characters to the left of that and 1 character to the right. A palindrome has the same characters on the left and the right. It's the same forwards and backwards. And so this has more characters in the front, so they can't be the same because this has more than on the end of the string. So in that case, we have a potential to terminate early. Right, so if we've gone here, we check this, we can check this next character here. And then if we go too far, well, then we're kind of done. And in that case, we wouldn't want to compare this B to the B and get left pal length. In that case, we'd actually want to go decrement our R pointer all the way over to here. Right, we don't want to stay on this character island. And you think about it, if we have a very long example, and we go, let's say we have these 3 characters here, and then we have 20,000 characters to the left and 20,001 to the right. And we have our island here that's offset to the right. There's no way that's going to form a palindrome that reaches the left. And so we would want to get off that and check the next character and go over here. We wouldn't want to go back to get left pal length and see if we got a palindrome there and keep expanding left and then right and compare those until we get to -1. We're never going to get to -1 because we're going to run out of characters on the right. Consider also if we have an island of characters of, let's say, C, where it expands 20,000 C's to the left and 20,001 to the right. Okay, then we're going to keep comparing C. Okay, we expanded all the way to the left and all the way to the right. Okay, and then we got back to get left pal length, and we can't find a palindrome that goes to index 0. So what would we do in that case? Well, in that case, we'd go I minus minus. Right, and so we have 20,000 C's to the left, and so now we were on the 20,001st. Now we go to the 20,000th C in that island. And then we would check all the characters to the left, all the characters to the right. We'd get our same island of C's again. And then we would go get left pal length. Oh, and then that wouldn't reach index 0, where L is -1. So then we would have to decrement I minus minus. So now we're on the 19,999th C. You see where this is going. We keep going C, 1 to the left C, 1 to the left C. There's 2 cases where this is super inefficient. The first inefficiency is obviously, well, that we've got something that's too far to the right. And the second inefficiency is that we're checking the island, the same island that we already determined wasn't forming the center of a palindrome. Why check it again? Doesn't make any sense. We already know it's not going to form a palindrome that reaches the left index, where L is -1. So there are 2 things that we need to figure out. The first is Well, if we need to figure out if we've gone too far. Okay, but we only have to worry about that really on the first time. So we can pass that, we can check that in same char outside bounds. Because if we create an island that goes too far to the right, then we can tell the calling function, hey, we've gone too far to the right. The calling function is get left pal length. Get left pal length says, hey, if we've gone too far, and how do we know? Well, same char outside bounds tells us we've gone too far. So same char outside bounds will tell us if we've gone too far. And if we have gone too far, we're going to pass a flag back to our caller, shortest palindrome. And then that loop, our outer loop in shortest palindrome, can check to see if we've gone too far. And if we have, then we're going to set our I, index I, we're going to set that all the way to the left of the island. We don't want to be stuck in that island and keep checking the same island. So we go all the way to the left of the island. So we can solve both of those problems. And so then the next time we go to same char outside bounds, do we have to look to the right of the island? No, we don't have to expand the island to the right any time other than the first. Oh, okay. So we only expand the island to the right on the first time in same char outside bounds. So there are a few optimizations we can find in here. Same char outside bounds is going to get this. It's going to get this is middle parameter. Is middle is determined in our outer loop on the first call if I is equal to mid. That's why we have that mid flag there. We didn't set I as math.c, we said mid. So now we've got that mid flag there. Well, there was a reason for that. The reason we have some asymmetry in our same char outside bounds as well. So first of all, we get this mid. Okay. Get mid, and then we check to see in the loop if I is equal to mid. And that's only going to be true on the first iteration. All right? Because on the subsequent iteration, we go I minus, oh, we don't have I minus minus there. We have it down here now. Okay. Oh, okay. Oh, okay. So if length is -1, ooh, there's a different flag. Now I is going to be equal to L. We're getting off the island. But if L is -1, so we have two sentinel flags. This was our first, then we call prepend tail. So we're going to pass in this is middle. Is middle is going to get passed in to get left pal length. Get left pal length gets this is middle param from shortest palindrome. On the first time, it's going to be true. Every other call, it'll be false. So we get is middle. We'll pass that into same char outside bounds. Same char outside bounds says if we're in the middle, I'm going to go over that too far. If we're in the middle, then we're going to see if we've gone too far. And we're going to define what too far is. And then we're going to go to the right. We're going to define what too far is. And then we know how far we can go to the right. How do we know what too far is? Let's first answer that. How do we know what too far is? Well, if we start in the middle character, okay, and then we move 0 characters to the left, how many characters can we move to the right? Let's go back to this example. We've got ASDF, FDSA. We start in this middle character. Index 3, character is F. How many characters can we go to the right? 1. We went 0 characters to the left. We can go 1 to the right. Okay, but if we have a 7-character string, how many characters can we go to the right? We went 0 to the left. Well, actually, we went 1 to the left because we advanced our L pointer to -1, but we didn't actually go to the left. How many characters can we go to the right? We can't really go any to the right. All right, so we can't go any to the right. So if we went to the right, then that's too far, and then we're done. We went too far. We went too far. If we go too far, we have to tell our caller that we went too far. What's our caller? Same char outside bounds, called by get left pal length. Okay, so then get left pal length is going to have to know we went too far. And what's it going to do if we went too far? It's going to have to get out of there. It's going to have to say we went too far, return the L pointer, and the R pointer is going to be -1. We're going to return -1 because we went too far. And we're going to return that -1 back to shortest palindrome. So then we can set, when the shortest palindrome says, oh, R is -1, that's a flag. Now we're going to set our L pointer. Our I is going to be equal to the L pointer, so we're off the island. All right, so let's go over this detail on too far. I minus L. That's how far we went left. But actually, remember L, we start out in L is, we decrement our L pointer. So the L is always going to be to the left of the R pointer by 1 or more. Okay, so then we have I minus L. -1, because it's always 1 to the left. It's always to the left of R by 1 more than the length. We've actually expanded that island. Okay, now we have to say if it's in the middle, well, if it's not in the middle, we just increment R by 1. That's it. But if it is in the middle, we have to define too far. So I minus L, okay, so we went, and then -1, because L is always 1, going 1 to the left of R. So it's always 1 ahead. So we have to subtract that. So let's say we started it at I was 3, right? And L, we go L minus L. Now L is 2. 3 minus 2 is 1. -1 is 0. Right, so we didn't actually go to the left. We just advanced our L pointer. We have 0 character distance. So now we're going to get with this statement here. S.length -1 modulo 2. So if it's an even length string, then we get an odd number. Modulo 2 is 1. So for even length strings, we're going to add 1. Ah, that makes sense, right? A, B, B, A. If we started here as mid, we can go 1 more. That's okay. If we're going to the right, we can go 1 more to the right. And that's as far as we can go. How far is too far? It's 1 more than we can go. So that's too far. Now we know what too far is. We only have to know what too far is on the first iteration, in the middle. Because if we're not in the middle, then we're only going to increment our R pointer by 1. Well, why is that? Well, think about it. If you go to the left of a string that has a very long character island here, and we start somewhere in the middle, here, wherever the hell it is, I don't know, somewhere in the middle, and we find out, okay, we're not going to form a palindrome because we went all the way to the left and all the way to the right, and it turns out, same char outside bounds found out that we went too far. Okay, so now we're going to send back, R is going to be -1. I'm going to send that back here. And so now we get to here, to this A character. Do we have to enter into a loop the second time in this A character? No, we just go R++. There's no need to see how far we have to expand our island to the right. Now we could have more A's to the left over here. We could start somewhere in the middle here, and then we go over here, and then we get off the island. Okay? Oops. We get off the island. We're on this A here. How far do we go to the right? We're only going to go 1. We expand our R character by 1, and then we can look to the left over here. And that's it. That's all we have to do. We don't have to keep going through a loop to expand it to the right other than the first time. So that's the modified same char outside bounds. Now we want to take a look at get left pal length in closer detail. So get left pal length, passed in the is middle, true only the first iteration, first time it's called from shortest palindrome. If R is -1, that's our flag that says too far. Then, if it's not -1, we're going to try to compare characters. We didn't go too far, so now we're going to compare the same thing we did before. The character on the left of the island to the character on the right of the island. And keep going and keep going and keep going until we get L is -1. At which point we terminate the loop and we return our success back. But if R was -1, we don't enter into that loop at all. We don't enter into that loop. If R is -1 or L is -1, we don't enter into that loop. It's the first condition of the loop. If L is -1, we don't enter. We don't do anything in the loop body. So in either case, we're not doing anything in the body of the loop. And we're going to return L and R to shortest palindrome, which once again down here, we're going to check the R, which comes back, and we call it length over here. If that's -1, then we get off the island. I is equal to L, as I said before. Now, if L is -1, we already saw that. We prepend the tail, taking the length. Otherwise, we had a normal island. We went through the body of the loop in get left pal length, and we just didn't make it. So we're going to try one character to the left of that. Okay, and that's how that works. So that's the whole shebang. Making this video was instructional for me. So thank you very much, everybody, for watching this video. Go check out the Solutions tab. If you've got any optimizations, and there are a few tweaks here that can be made, if you can see that, then please let me know how you would like to improve on this function, because I would genuinely like to know how this function can be made better. Thanks again for watching.